And today I want to talk to you about building and running microservices in the cloud, but without having to set up any servers, right? No having to provision virtual machines, no having to log into some Linux environment and set that up, no having to install application middleware or databases. And that might seem to you kind of impractical or even impossible, right? If I've got some code, I need to run it on some servers, and sure, I have to set up and manage that environment. But I'm going to show you a new approach using what they call serverless cloud platforms to do just that. And in the second half of this talk, I'm going to be developing a live application on Sage using one of these serverless cloud platforms to give you the tools and techniques to do this yourself. You know, you might also be thinking, right, as well as this sounding slightly impractical, right, microservices without servers, it also sounds unnecessary. You might think, you know, I like my servers, I've got them set up just how I want them, and I can log in over SSH and copy my WAR file in to deploy my application, right? Why would you want to take my servers away from me? Well, the reason is this, right? Servers are killing your productivity, and you might not realize it yet, but trust me, it's true. And I think by the end of this talk, you're going to agree with me. You're going to want to go back to your office, gather up all of those Ubuntu machines that you've got, set them on fire, and be free of the tyranny of looking after infrastructure. I think servers are one of the worst things that's ever happened to software developers, and they are directly responsible for you being a worse engineer, writing less code, delivering worse products, making less revenue for your company. But how is this possible, right? How is that little Ubuntu machine that sits in the corner of your office warming your feet responsible for all of the evils that I've just talked about? Well, let me walk you through a story to help emphasize why I feel so strongly that servers are killing your productivity. You wake up one day and you've had a fantastic idea, right, for the next billion-dollar unicorn startup, right? This is going to be the next Facebook, the next Google, the next Microsoft. You've got this idea, you understand the problem, the market, there's product market fit and all that kind of stuff you hear about on Silicon Valley, and you've got the skills, right? You can write code to turn it into a reality. So you spend the next couple of weekends furiously coding away, trying to get to the version 1 of your application, right? Minimum viable product that you're going to do. So you've got your code, and you've got some customers who want to try it out. So you think, I know, I've got my code, I've got some customers. The next thing I need is a server. I can get a server, I can put my code on there, customers can start to use it. They'll give me feedback. I'll go through this whole lean development lifecycle. I'll push out version 2, and within a short amount of time, I'll be building the next Facebook, right? I'm going to be the next Zuckerberg. So you get your code, you run it on the server, you email the link out to your friends, and then what happens the first weekends when your application is live? Well, the hard drive fails in that server you borrowed. So now, rather than using your application, users are staring at a blank screen. And mad panic, it's Sunday, you can't find the hard drive, you need to get one to install it, you've got to put the environment back on there, get all the services installed, get your application back up. And while this is going on, right, your application's down, no one is using it. So eventually you find the hard drive, you put your environment on, you get your application back up and running, and just as you're about to make your application live again, you get an email. And the email says that there's a vulnerability in the version of Linux that you're using on your Ubuntu server. And you don't want hackers to break in and steal all of your valuable customer data. So now you've got to patch your kernel, and that means taking your application down again. Again, no one can use your application. So you patch your kernel, you think you're ready to go again, and then you realize there's an update to the version of your middleware that you're using. So you think, well, my application's already down because I'm patching my kernel. I'll just quickly update this middleware. But when you do that, it requires you to update libc, and then that clashes with the version of the database you're using. And suddenly, what should have taken 30 seconds takes hours and hours and hours of upgrading all these transitive dependencies. So you've installed the new hard drive, you've patched your kernel, you've updated your middleware, you think, okay, that's all in the past now. Now I can get back to working on my application. But when people start to use your app, suddenly you realize you haven't anticipated how much network traffic it generates. So now you need to upgrade your network infrastructure, and that requires you taking your app down again. And also your server obviously needs more memory and a bigger CPU, right? It can't cope with the amount of load that users are creating. And suddenly, while you're worrying about all this hardware stuff, right, ordering that new memory, CPU, the network infrastructure, you're not paying attention to monitoring your application. And if you'd looked in the logs, what you would have seen is that your database table being corrupted. So the index has been wiped out by a bug in your database driver, and suddenly the main query in your app is running extremely slow, users are having a really bad experience, and it's all going terribly. And what you realize is at this point that this little server that you had to run your application is completely overwhelmed. It just can't cope. And the solution most people come up with in this scenario, right, is to get another server. Maybe I'll get 10 servers, then I can run them in parallel, then in a cluster, and worry about scaling and replication and fallover. And suddenly you spend all of your time managing these servers, right? Looking after kernel patches and hardware upgrades. And all of this time is time that you're not building your application, right? Writing code, pushing out new versions, listening to your customers. It's as if you're being held hostage by your servers. Now you might think, hold on, James, right? Wasn't the cloud supposed to fix all of this? I'm always been told that I have to put my applications in the cloud, building cloud-native architectures, use everything as a service, and all of these infrastructure issues magically go away. And we're told about these companies like Netflix, like Etsy, like Uber, who've had great success building their startups in the cloud. And often we're sold this utopian vision, right, that cloud computing makes computing resource like a utility, right? Like electricity or gas or water that you can turn on or off on demand. But for many of us who are kind of aggressive early adopters of early cloud systems, think of kind of infrastructure as a service, what it turned out to be was renting virtual machines in someone else's data center. So maybe I didn't have to physically buy the server and plug it in, but I still had to manage everything myself from the operating system up, right? I had to still patch those kernels when vulnerabilities came out. And this isn't how I think of a kind of utility model, right? I think this is a bit like if you built a house and you wanted to connect it to the electricity grid, and you ring up the power company and you say, right, I'm ready to get connected. And they say, well, we can't just connect you directly, right? But what we can do is we can bring around all the parts so that you can have a substation in your backyard. And we'll manufacture it so you don't have to do that, and we'll set it up. But you have to maintain it when it's running. It's going to be running 24 hours a day, whether you're using it or not. And also, you need to predict how much electricity you need in 12 months' time so we can decide how big a substation to bring. And that's not how I want to get electricity in my house. So it seems like there was no escape, right? Even if we're using this cloud thing, right, we still had all of these servers to look after. And it's not just money, it's not just time that you waste, I think, managing servers, it's money. So Google did a study in July 2013 looking at their utilization rates of some of their bigger clusters. So these were clusters with something like 30,000 machines in, and they found that the average utilization was just 20 to 40%. And this meant that 60 to 80% of the time, those servers were sat there, those applications were sat there idle, waiting for requests to come in. And if you're renting virtual machines by the hour in some public cloud provider, you probably have similar utilization, which means you're probably spending money and getting no return on investment. And again, if this is, and this is money, right, that could be better spent on anything, right, on paying more developers, on advertising, on market research, anything to get a better product. And if this is supposed to be, a utility model of computing, right, this is like having that water tap in your house, and you have it running 24 hours a day, regardless of whether you're using it, just in case you need to go and get a glass of water in the middle of the night. So, right, what can we do? And I think the first step to getting, to recovery is admitting we have a problem. And I think the problem a lot of software developers have today is managing servers. But what's the solution? It seems to me that we're in a bit of an impossible scenario where surely we need some servers to run our microservices, to run them in the cloud. But every time I go near these Linux machines, it just kills my productivity. And then I think something really interesting happened at the end of 2014. Interesting if you're like a cloud nerd like me. Was that Amazon launched a new service for their cloud called Lambda. And Lambda, this is Werner Vogels, their CTO, introducing it on stage. And Lambda was supposed to be this next-generation cloud computing service that allowed you to treat computing resource just like a utility. But you wouldn't get that if you read their press release. The press release said, it runs code in response to events. It manages computing resources. It allows developers to build kind of, event-driven applications. And that doesn't, to me, sound very exciting or revolutionary. And it sounds like pretty much every other cloud system out there. But Lambda was different. And it was different for a couple of reasons. The first is that it shrank the unit of deployment. So rather than deploying your application as a big VM with all your application services coupled in there, or even as a kind of monolithic deployment package, you could literally just deploy those microservices, those functions that you wanted to run in response to external events. And the platform will handle everything else. When a request comes in, on demand, the platform will start a new instance of your microservice, execute it to process the request, and then kill it off after. You don't have instances of your services running, waiting for requests to come in. And now we don't even have to think about servers, right? Your code might as well be running in an actual cloud in the sky for all of the interaction you have with the underlying infrastructure. So what happens if your service is running on this platform, right? Processing a request and another request comes in parallel. Well, with Lambda and systems like it, it scales up. So all it has to do is execute another instance of your request in parallel and process that request. And that means that we don't have to think about kind of predicting traffic load, right? How many requests per minute can this server handle with this hardware configuration? Everything is done by the platform. And it means we can cope with kind of almost infinite load. And as well as scaling up, it also scales down because you're only running code when you're actually processing requests. So most of the time, your application's idle waiting for requests to come in. None of your services are actually running. And this is important when we think about the pricing model for Lambda and systems like it. Like all cloud systems, right, it's pay as you go. So you only pay for the resource that you use. But with Lambda, you're only running code when you're processing requests. And this can lead to some extreme cost savings. So there was a Business Insider article about Lambda when it came out. And they profiled this customer who was a cybersecurity firm, right? And they had an application that was doing kind of analytics on logs that were being generated by the customers. And previously, it'd been a couple of VMs running on Amazon's cloud. And most of the time, their application was sat there doing nothing. It was idle. It was just waiting for these logs to be generated. So they'd heard about this Lambda thing, and they decided to rewrite their application using this new architecture. And suddenly, they saw a dramatic reduction in their cloud bill, right? They saved 80% on their monthly cloud bill, which was a significant amount of money for them. Because now, they're only paying for the resources their application was using when they were actually kind of doing stuff with customer logs. Now, you might also think at this stage, hold on, this doesn't sound that new to me, right? Isn't this just platform as a service? Maybe I use Cloud Foundry or Heroku or App Engine, and I don't have to think about logging into setting up Linux servers. I can kind of scale dynamically when my application load changes. And it's a good question, right? And I think there is some similarities between what I think of as service cloud platforms and platform as a service, but there's some key differences. And I think the best response to this question comes from Adrian Cockcroft, who was CTO of Netflix for a long time, is obviously a visionary guy in the cloud space, and was having this debate on Twitter about, what is serverless versus PaaS? Is it really any different? And what he said was, if your PaaS can run instances in 20 milliseconds or start instances in 20 milliseconds that run for half a second and then get deleted per request, then you can call it serverless. Otherwise, it's not. It's a more kind of traditional model of cloud computing. And I think this is true. Like, I love PaaS. I think Cloud Foundry is fantastic, but it's definitely different. You don't have instances of your services started on demand for every single request. So Lambda launched at the end of 2014. You can see a little spike when it launched at Amazon's conference. And its popularity has been steadily growing ever since, right? As developers have realized the benefits of being able to just deploy microservices without thinking about servers. Scaling's easy. There's huge cost reductions. But then this year, something else I think really interesting happened, which is this whole serverless term took off. So you can see the second uptick in 2016. And serverless really refers to the whole kind of ecosystem of vendors and providers and frameworks of allowing you to build new applications for the cloud in this way. And the reason I think it's really kicked off in 2016 is that all of the major cloud providers have launched their own kind of similar solutions. So we have IBM has one called OpenWhisk, which we'll kind of be looking at later. Microsoft have one called Azure Functions. We've got Google Cloud Functions. We've got WebTask, we've got Iron.io, who are kind of smaller providers. So all of the major cloud providers now have solutions for kind of building and deploying services like this. But I think the real measure of kind of popularity for any kind of developer technology, right, is conferences, right? Conferences like today. And this year in 2016, we had the first serverless conf. So it was in New York back in May. It was incredibly popular. It was sold out. It had brought together all the big providers and developers and frameworks and that kind of stuff. And it was so popular that they're running it again, the organizers, twice this year, once in Tokyo and once in London. I think it's a true measure of the kind of interest in this technology that they've managed to pull off 3 events this year. So, but before I go any further, right, I wanna drop in a little spoiler, right? I don't want to mislead you at all. And the spoiler is that there's still servers, right? There's still going to be servers out there. Whenever your code's running in the cloud, right, it's still running on some virtualized Linux instance somewhere. But the term serverless refers to the developer experience, right? From a developer's point of view, your code might as well be running on a cloud in the sky for all of the interaction that you have with that underlying environment. So enough talking, right? Bring on the codes. Let me show you how to actually use one of these platforms and give you the tools and the techniques and the patterns to be able to use them yourself, and talk about some of the advantages and then also look at some of the challenges. So I need something to build, right? I need an idea for my next billion-dollar unicorn startup. And a couple of weeks ago, I woke up and I had just an idea, and it's about the weather. Now, one thing you might not realize about British people, and I'm from the UK, is that we're obsessed by the weather, right? We live to talk about it with our friends, to worry about whether it's going to affect our holiday, to watch the forecast every evening, mostly because where I come from in the UK, it's really bad and it rains most of the time. And working in technology, I also know one of the major trends this year has been bots, right? Everyone's building bots for everything. Facebook have got their whole messenger bot platform. Microsoft have launched this bot building framework. So my idea was, could I build a weather bot, right? A bot to help me when I'm worrying about the weather, maybe to get forecasts on demand, maybe to advise me when it's going to be, particularly terrible like this. And as a British person who worries about the weather, I'm also a software developer, which means I love using Slack. So Slack's my kind of preferred communication tool for working in teams at work. And I want to see if I can build a Slack bot, my weather Slack bot, using this platform. And I've heard about this serverless thing, and I thought I'd kind of give it a go to kind of try and build my next big startup. So we've got our idea, right? We're going to build this Slack bot for helping us with the weather. The next thing I need is a serverless platform to play with. And today I'm going to be using IBM OpenWhisk, which we announced back in February and is available on our cloud. And you can go and sign up for a free account, as with everything these days, and get started with a fully provisioned serverless platform. And everything I'm going to show you today, you can do within that free account, right? So you wouldn't have to pay any money. But the important thing to note here is that the techniques and the tools and the patterns and the architectures I'm showing you today of using these serverless platforms is applicable to any vendor. So whether you want to go and use AWS Lambda or OpenWhisk, or you want to use Google Cloud Functions, it's the same kind of techniques. But I think if you're going to evaluate your choice of serverless platform, there's a couple of good reasons to look at OpenWhisk. The first is that it's completely open source. So when we made the platform, we announced it back in February, we put all of the code upon GitHub. You can go to github.com/OpenWhisk, dig around in the Scala code if that's particularly interesting to you. And the reason we did this is because a lot of developers using any cloud system are really worried about vendor lock-in, right? They're worried about being tied to some proprietary set of vendor APIs or proprietary services that they can never get off if it shuts down or they change the pricing model or something like that. So we think building our cloud on open source components helps to kind of mitigate some of that risk. Now, OpenWhisk uses under the covers very, very standardized, kind of battle-hardened open source components. It uses Kafka, it uses Console, it uses Docker, so there's no secret IBM source in there. But a great thing about it is their team continues to develop in the open. So if you go to the GitHub project, you can look at the milestones and see what kind of features are coming up. You can submit feature requests. If you get bugs, you can submit issues, and you can also get your code in there. So you can submit pull requests to get new features in the platform, and we're really trying to build an incredibly vibrant open source project around this. So if you want to run this locally, because it's open source, with these 3 commands, you can have the full service platform running in your local development environment, right? Check out the code, CD into another directory, and spin up a Vagrant machine, and all of the services will be kind of spun up for you. And this takes around 20 minutes to do the build, but you can have the whole thing running on your laptop. But for most developers, I think what's easiest if you want to kind of try this out is just to sign up for a free account with Bluemix, and you can provision yourself an OpenWhisk instance to play with. You don't have to set anything up, and it'll all be hosted for you, so you don't have to do anything. It's currently in beta, so there's no charge for doing anything, so it's a great time to go and try it out. And you get some extra tooling to make it a bit easier to use. There's an in-browser code editor, and there's monitoring analytics and all that kind of good stuff. Another great thing about OpenWhisk as a provider, as an open source provider, is its runtime support. It supports all of the major runtimes that I expect from most serverless platforms. So 2 versions of Node, V12 and V6, Java 8, if you want to write your microservices in Java 8, you can do, Python 2.7. And if you look at all of the serverless providers, Lambda, Cloud Functions, OpenWhisk, they all seem to support those 3 out of the box. One of the things that OpenWhisk supports that some others don't is Swift. So Swift was a language developed by Apple for writing mostly native mobile applications on iOS, and then they open sourced the language a couple of years ago, and it's becoming incredibly popular with developers. And the reason that we've decided to include kind of first-class support for OpenWhisk, or for Swift and OpenWhisk, is that I think a great use case for serverless is mobile, right? Building mobile backends, mobile APIs, and it means that those developers who are comfortable building, native Swift applications for iOS on iPhones can easily knock up some backend services in the same language. But by far the best thing about runtime support in OpenWhisk is that it's extensible. So if you want to write your microservices in Haskell or Kotlin or Elixir, anything you can wrap in a super lightweight Docker container, you can push directly that image into the platform and have it executed on demand. So you're not stuck with just the runtimes that the provider supports out of the box, so Node, Java, Swift, Python. You can execute pretty much anything as one of these serverless functions. So we're going to use OpenWhisk, right? We've got our idea for Weatherbot, and we're going to use OpenWhisk for some of the advantages I just talked about. The next thing I need some microservices, right? I need some code. And codes might look a little bit like this, right? myservice.js. And today in my examples, I'm going to be focusing on the Node.js runtime, because it's the runtime that I'm most familiar with, and I think most people can kind of grep JavaScript. But the question is, right, once you've developed your service and you want to deploy it to one of these serverless platforms, how does the platform know what to do with it? As I said, you don't have to write loads of configuration for your application. You don't have to bundle it up in a big deployment package. You literally push your code straight into the platform. So for every runtime that you want to use, there's a tiny little interface that you have to add to your code to act as the kind of entry point for the platform into your code. So when a request comes in, it's going to call that interface and dynamically on demand execute your code in the cloud. So for example, what does it look like for JavaScript? It looks like this, right? So you can have a JavaScript file with your service in. It's 1,000 lines long. It can have hundreds of different functions, and all it needs to do, calling third-party NPM modules, and all it needs to do is have a single public function main that is actually the interface. So whenever a request comes in, the platform's going to dynamically evaluate this code and call your function, and then you can do anything else. Request parameters are passed in as an object, so you can pull the request parameters out, and everything that you return will be serialized as the JSON response. So you can see it's a very lightweight interface. You don't have to do a lot to your microservice once it's written to make it compatible with one of these platforms. Let's have a look at what it looks like for Java. We'll have a quick drink of water. So Java, this is the same in Java, right? It's super lightweight. You've got your class file with your Java code in. And all you need to have is a public static main, which takes a JSON object and returns a JSON object. So you can do whatever you want in your code to compose your service. And that's all you need to add before you can push it into the platform. And if you've written your services and you want to push them to OpenWhisk, when you do this, OpenWhisk creates what's called an action. So an action is the name that we use in OpenWhisk world for talking about your dormant microservice that's been deployed, that's waiting for requests to come in. So let's actually have a look at doing that now. Let me show you taking some microservices from my laptop, pushing them up to OpenWhisk and kind of running them on demand without having to even think about setting up a server. So if I drop out of my keynote, I do that. Should be able to see my screen. I can go like that. It's a bit better. So I'm going to use OpenWhisk that's deployed on IBM Bluemix because it's already set up and ready for me to go, and I don't have to download and run anything locally. And if you do, and you go and sign up for a free account, as I said, there's like an editor, a browser-based editor, so you can try it out without even having to kind of install anything locally. There's a monitoring and analytics engine to kind of monitor your services when they're running in production and help you keep everything good. But I'm a command line kind of guy, right? I like to develop locally in Vim and then push my services up to the cloud. I'm going to be using Node.js. So to do this, we need some way to interact with the platform. And OpenWhisk provides you with a little CLI. So this is a little, obviously, command line interface you install locally in your terminal, and then you can kind of interact with the platform. And you have to, once you've done that, obviously authenticate with your user account that you've registered with. But I've already done that. So if I go to my terminal now, you can see that. I'm going to type WSK, Whisk. And you can see that I have this little command line utility that I can then kind of talk to my kind of cloud platform with. And I can do everything like saying, you know, show me the actions that you've got deployed and invoke them and all that kind of stuff. So let's look at taking some sample code and kind of running it as one of these serverless functions. So I have some sample code here. Let's look at this first one called hello name. I think of this as the world's smallest microservice, right? It's the most useless microservice, but it's probably also the world's smallest. And what it does is it returns you a greeting with your name in it. You can see that we have implemented the interface that OpenWhisk expects, right? All my code can live within the function main, takes some params, looking for a user, and returns an object which can serialize back as a response. So if I want to deploy this and run it as one of these serverless functions, I can do that using this utility. So I say whisk action create. I'll give it a name. I pass the path to the code. Looks like it's been deployed. So let's check. Yeah, that's all working. Great. And then I can invoke it, right? So I say invoke hello name. And hopefully, there we go, right? So there is a result of my code being executed somewhere in the cloud. And I can pass in a parameter. I can say my user. I'll give it my name. And hopefully, it should be a different result. Right? So there we go. There's our first kind of little serverless function running in the cloud. No servers in sight. And you can do this for, as I said, any language. Right? Let's look at Java. This is a little class file which re-implements that tiny but useless microservice. And again, we've just got a public static main which takes a JSON object and returns a JSON object. Java, you have to do a couple more things. I've got to compile my Java code. I've got to add it to a jar. And then I can deploy it. So I say whisk action create, give it a name, hello Java, and give it the jar file. And then I can invoke it. So I can say whisk action invoke the name. And I give it, what does it expects a name, right? James. And so it's going to dynamically evaluate that on the JVM in the cloud and give me back the result of my code. So, you know, no servers in sight at all. So you can see how easy it was to get started, right? All I have to do is worry about my code, make sure it's got that interface, and I can use the utility to deploy it and invoke it on demand. But what I'd like to do is use OpenWhisk to develop my amazing WeatherBot idea. And I think WeatherBot has to do a couple of things. It has to be able to take an address from a user and work out where that is in the world, right? What is the location? It has to be able to do forecasts. So from that location, give me a forecast. And it also has to have the integration with Slack, like posting messages as a bot, be able to get them back. And I could write all of these services as one kind of monolithic service and deploy that. But I want to follow this microservices idea of keeping them all separate, and then we'll look at an interesting feature of the platform later on to actually join them together to create my sample bot. So to save me having to type everything out on stage, I've actually started to develop some of them already, and I want to just deploy them to the platform. So let's have a look at my first service, location to lat long. So this is a service that can do those address lookups, right? It can give you an address and will tell you the latitude and longitude of where you are in the world. It uses a third-party geocoding API that I've signed up for, takes one parameter address, makes that HTTP post or HTTP get call, and then returns you the result asynchronously. So I can deploy this on as a serverless function, give it a name, path to the file, and then we can invoke it, right? So I can say location to lat long. Give it an address, obviously. Let's try Belgrade. See if you know where we are. And there we go, right? There's hopefully that's the latitude and longitude of roughly where we are today. So that's the first service for my bot up and working. Let's have a look at the next one. So again, this is a service which uses, this does forecasts, right? So for a location in the world, what's the forecast like? And it uses a third-party API that I've signed up for an account with to get forecasts for next week, and then it gives me back at the bottom the kind of text description of what the weather's like at the moment. So let's deploy this. Give it a name, forecast from that long. And then let's invoke it, right? So I can test it. This takes a few more parameters, right? So I need a username, which I've got in an environment variable, and it takes a password, and then it takes, so I need latitude and longitude, right? So where were we? It says we were at about 44. Parameter long, I think it was about 20. So now, hopefully, if it works, it should tell me, let's have a look. Oh, there we go, right? I've got the name wrong. There we go, right? Nothing like a mid-stage panic. So there's the text, right? It says clear, low overnight in the low 40s. Sounds about right. So that's my first two services, right? So I can now do address lookups, I can do forecast lookups. The next thing I need to think about is integrating with Slack. And Slack's a great platform if you've not played with it for building bots, because it provides some really nice ways to kind of integrate. So I go back to Chrome. And one of the ways you can integrate is using webhooks and what they call incoming webhooks. So in my Slack group that I've got open, right, we have this weather channel, which we use to worry about the weather. And I've started to create an incoming webhook for it. And what incoming webhooks do is give you a URL, all right, a unique URL for the platform that you can post JSON to, and it will turn up in the channel as a message from a bot. So I can now write a service that uses this unique URL to be able to post those forecasts into the channel. And I could write that service myself, but actually what I'm going to do is take advantage of what they call packages in OpenWhisk, which provide integrations for lots of third-party services. So rather than having to write that code myself, I can just pull one out from the system. So if I go back to my terminal for a second, you can see what packages come installed with your version of OpenWhisk using Whisk package list. And I can see, right, it says there's already a package for Slack integration built in, which means I can say Whisk package get, I give it a name, I just want the summary. And it tells me that there is an action, right, a little microservice already deployed for kind of integrating with these services. So now I can invoke it without having to write any code myself, right? So I know it needs to take a URL. It needs my URL, my webhook. Let me put that in quotes. And I know it needs a channel. And I know it needs some text. Hello. And hopefully if that works, then you should see pop up in Slack a little message from my bot, right? So rather than having to write the code yourself, you can often, with OpenWhisk, use a lot of the third-party integrations. Now, I wanted to change like the bot emoji and the title, so I've actually copied that default system package and made some changes and deployed it in my workspace. So I have this little action called webhook that I can invoke, and I've also bound some default parameters, right? So I don't have to do things like give it the username and password each time. So let me have a look. Risk action invoke, webhook, text, hello. And hopefully, there we go, right? So there's my little weather bot. Now, let me, before I go on, say, you remember in the last microservice, I was using kind of usernames and passwords for a third-party API I'd signed up for. Now, one of the things that you don't want to do, you don't want to embed those credentials in the code, right? But also, I don't have to pass them in with every request, because that's kind of cumbersome. So one of the things you can do with OpenWhisk is create what's called default parameters that the platform will manage and pass in for you. So with our microservice that uses that third-party API, rather than passing in the username and password every time, I'm going to update it to use these default packages. So I can say a Whisk action update, and it was called forecast from lat long. And we will pass in, let me just copy them from above. I copy these, I'm going to copy the username and password. So hopefully now, I should then be able to invoke that with a lat of, what was it, 20, longer 44. And hopefully, right, it should give me better results without having to do anything. So now I've used what they call default parameters in OpenWhisk to store those credentials so I don't have to pass them in anymore. So we've got our three kind of microservices, right, that I've started to develop for WeatherBot. And what I want to do is kind of join them together, right? I want an event to trigger with an address, and I want the forecast to pop up in Slack. And again, I could write some code to do this invocation myself, but we're going to use a feature of the platform called sequences to be able to do this. And what sequences allow you to do is create kind of meta services that say call this service and call this service and call this service in order, passing the output from one to the input from another. So you can think of this a bit like Unix pipes, right? With Unix pipes, you write one command on the command line in the shell. There's multiple programs, and the operating system, the platform, handles piping the output from one to the input from another. So let's try that now. Let me say whisk action create, location forecast, and then we're going to say it's a sequence. And then I can just give it the names of the services that I want to call. So I can say I want to call location to that long, and I want to call forecast from that long, and then obviously I want to call my webhook service. And then hopefully, if I now invoke that service, location forecast, I have to pass it an address, right? The parameters of the first action in that sequence. Belgrade. Hopefully, if everything works, there we go, right? There's hopefully the forecast for Belgrade that's popped up in the service. So I've used this neat feature of the platform I think is great called sequences to allow me to join together my microservices without having to write any code. So let me pop back to my slide now before we go on and continue to develop WeatherBot. Do that. Cool. So once you've got your services deployed on the platform, right, how can you invoke them? How can you integrate them with your applications? And in OpenWhisk, there's two ways to be able to do this. The first is through the platform API. So OpenWhisk as a platform has a really, really comprehensive REST API for doing everything from deploying your services to invoking them to getting the results back. So when I'm typing using the command line, all it's doing under the covers is sending these REST API requests. And every action that you deploy has its own unique HTTP endpoint that you can send an authenticated HTTP post request to invoke it on demand and get the results back, and use your developer credentials that you signed up with to be able to make that request. Now this presents us with a bit of a challenge if we want to if we want to be able to call those services right on demand and kind of integrate them within your application, because I don't want to expose my credentials out to the world, right? I don't want to expose them. I can't put my credentials in a client-side web app. So one of the things that we can do is use what they call an API gateway service. So an API gateway is a third-party cloud service that allows you to create public endpoints that then proxy private APIs in the background. All major cloud providers have these. So Amazon has one, IBM has one, Google has one, Microsoft has one. And the pattern for doing service development for public APIs is to use one of these API gateway services to be able to create your public endpoint. So then we can obviously integrate in any application. But what about kind of asynchronous processing, right? What about having my microservices listening to messages on a queue or database updates and invoked on demand? Because again, one of the big use cases they talk about for serverless is this kind of asynchronous processing. Well, in OpenWhisk, we handle this through something called triggers. So you can create triggers which model events from the outside world and bind them to things like database updates and messages on a queue. And then once you have those, they'll get fired on your behalf. And then in a system, once you've created your trigger, you can actually create a rule that binds it to an action. So it says whenever there's a new database update, there's a new message on a queue, my trigger gets fired, and then it means that my action gets automatically kicked off. And this is how we can handle that kind of asynchronous event processing. So let's jump back to WeatherBot now and kind of add some features showing you both of those ways of invoking your serverless functions. So one of the things I would like to do to extend WeatherBot is I would like to be able to talk to it, right? I would like to be able to ask messages in the channel and kind of demand forecasts for particular locations. And again, I can do this using Slack's webhook integration. So Slack has what they call outgoing webhooks, and I've started to create one. And what outgoing webhooks do is say whenever someone says a trigger word in a channel, right? In this case, the word weather in the channel weather, I want you to post that message to some third-party URL that I provided down the bottom. Now, for my microservice I've got running, location forecast, I've used an API gateway service previously to set up a public endpoint that we've registered here, right? So here's the public endpoint for that microservice I just created. And I can click Save Settings. So now if I go back to Slack, oh, thanks. Whoa, you're watching nothing. I got 10, okay. Yeah. So let me run through that quickly again, since you couldn't see and I didn't realize. So outgoing webhook, right? You can say whenever someone says a trigger word in a channel, post the data to this URL, and then the response comes back as a bot. And I've set one up for my channel, which means that I can come back into Slack, and hopefully I should be able to say weather London, and it gives me back the response. And I could say weather Belgrade. And the webhook fires, which fires my API gateway, which fires my serverless functions, which finally calls the inbound webhook and talks to Slack, right? So I've got WeatherBot now available on my channel. I can kind of request forecasts on demand. And the next thing I'd like to do is hook it up to some kind of asynchronous event source, right? And one of the things I'd like WeatherBot to do is to be able to tell me when there's weather coming up, right? Bad weather. So for example, maybe it could tell me what the weather is going to be like every morning so that I know whether to take an umbrella to work. And to do this, we're going to use triggers, which I just talked about. So you can create new triggers in the console. So I can say whisk trigger create, right? And I can give it a name, my trigger. And then I can create a rule, which binds a trigger to an action. So I can say bind my trigger to location forecast. So now if I fire my trigger, my action should be kicked off automatically. So I can say whisk trigger fire, my name, I give it a parameter, so I give it an address. And hopefully, if that works correctly, there we go, right? So my asynchronous event's been fired, and my service that I've got listening to it is fired off. And you can have lots and lots of different actions all listening to the same trigger. But what I'd like to do is connect my trigger to some external event source so it's fired automatically. And one of the event sources that comes built in with OpenWhisk is an alarm package. An alarm package that allows you to, alarm package that allows you to say, every morning or according to a pre-specified schedule, right, invoke my trigger automatically. And that means my microservice will get kicked off, a bit like a cron job. So there's an example here of creating a trigger that fires every 8 seconds. So I can say, I give it some data. There we go. So this is a trigger that hopefully should be firing every 8 seconds. And then I'll create a rule, a regular forecast, right, that binds this trigger every 8 seconds to my location forecast. So now, hopefully my trigger's been fired automatically, my microservice should be kicked off, and we should see lots of messages in the channel. So if I go back to Slack, there we go, right? You should see every 8 seconds the new message for the forecast for London coming in the channel. So I'll never again need to know whether the weather's going to be like. So let me go back to Keynote now and kind of finish off. So that was how you can invoke your actions, your serverless functions, once they've been deployed, directly through the platform API or indirectly using these trigger things that we've just talked about. So hopefully if you've been kind of following what I've been doing in the past 40 minutes, hopefully you're really kind of excited about this new serverless thing you've heard about, and you're so excited you're ready to go back to work on Monday and tell your boss about this thing you heard about at this conference. And apparently the guy said that you can get all of your servers, you can set them on fire, and you can be free of the tyranny of looking after infrastructure forever. Right, but before you do that, I want to give you some of the challenges of building applications using what they call serverless platforms. So the first challenge that I want to kind of talk about is some of the trade-offs and constraints and challenges that come with using these kind of architectures. And the first thing to talk about is compute limits, right? So serverless platforms are very opinionated architectures, and they're very opinionated about the kind of applications it expects to run, right? I'm never going to think it's a good idea to go and rewrite your legacy COBOL application that runs payroll and put it on OpenWhisk as a set of serverless functions, right? It's just not designed to run that kind of application. It's for modern cloud-native microservices. And one of the ways that it enforces this architectural style is through limiting the resources that you have available to you when your services are running. So these are some of the kind of parameters that get enforced when you're running on OpenWhisk. And this is the same for all serverless platforms. So it's things like your microservice has to complete its execution for every request in a maximum of 5 minutes. If it doesn't, it gets killed and it just doesn't execute. Same with memory. So for example, if you you can change the amount of memory available for every microservice up to a maximum of about 0.5 GB. But if you're doing something that's super memory intensive, right, some long batch job, Bitcoin mining for hours, is not going to work running on one of these serverless platforms. But I think that one of my favorite phrases is that constraints are liberating, because often when you're following a set of architectural constraints, you get lots of kind of unintended benefits from it. And I think it's true with serverless, right? The reason that it's so constrained on the resources is to force you to follow a kind of architectural style that's designed for the cloud. So for example, your microservices have to be stateless, right? Because they don't exist between invocations. You can't use application state to store, kind of data between requests. But the kind of unintended benefit of that is that scaling becomes easy because the platform can handle it. For every request, all it has to do is spin up a new instance of your service. It doesn't have to worry about replicating difficult stuff like application session state. Monitoring, debugging, and testing, right? These things are all the kind of tasks that you need to do to keep your application kind of healthy and up and running. And monitoring and debugging are especially challenging with kind of serverless platforms because a lot of the tools and the techniques that we have for doing this kind of stuff relies on you having physical access to the environment, right? Being able to SSH in, to grep through the logs, to attach some debugger to an errant process, or to kind of trace system calls. And you can't do any of that because you have no access to the environment. So one of the things that you need to do, right, if you're going to use this kind of serverless platforms is making sure your microservices have really, really good logging output, right? Because you still have access to system out and console error and things like that, and you can use these to diagnose problems after the fact, but you can't just SSH in and attach a debugger. Unit testing is another kind of interesting thing. I think it's both really easy and really hard, right? Yeah. Unit testing, kind of small things is relatively easy because you can whip up a quick test harness to be able to kind of simulate running in production. But system testing is quite difficult because it's quite hard to be able to simulate exactly running on someone else's cloud platform. OpenWhisk can kind of help a little bit with this because you can run the whole system in your kind of environment and kind of replicate system test a little bit more. So I'm kind of a little bit short of time, so I'll just kind of skip to the conclusion and get on with it. Complexity is another challenge of building applications in this way. If you are someone who's used to building a monolithic kind of Java application that you just deploy as a single WAR file, the idea of having dozens of different functions running in parallel, all talking to each other on someone else's infrastructure, probably fills you with dread, and it should do. It's a much more complex way of developing kind of applications, and it's one of the downsides, I think, of microservices. But one of the ways with serverless that you can help to manage some of that complexity is through frameworks. So there's lots of popular open source frameworks that you can use. There's one called the serverless framework. That's probably the biggest one out there today. It allows you to have all your configuration as code. It allows you to automate deploying your services, rolling them back if you get into any difficulties. So if you're definitely going to look at using service platforms, look at some of the big frameworks to kind of help you get started. So I said at the start of this talk, right, that servers are killing your productivity, and hopefully now you agree with me, right? All that time spent patching your kernels, managing your VMs, upgrading your infrastructure is time that you're not spending on building your application, right? We're being held hostage by our infrastructure. And for me, a lot of the time, I felt like the dog in this cartoon, right? All my infrastructure was on fire all of the time. My kernels were panicking, my disks were overflowing, but I just convinced myself that this was fine, right? This was the best way to develop applications for the cloud. And then this serverless thing came along, and it had all of these benefits, right? You didn't have to worry about servers anymore. It was functions as a service. Scaling was easy. There was huge cost benefits. And now, I just didn't have to worry about any of these Linux environments. So if you're thinking about building applications to the cloud, I encourage you to embrace this serverless revolution, right? Burn your servers, deprovision your VMs, be free forever of looking after the tyranny of looking after infrastructure. But most importantly, upgrade your productivity, right? Stop spending your time looking after your Ubuntu servers, get back to writing code. So thank you very much for listening. If you want any of the resources from that talk, there's a GitHub repo at the top, bit.ly burn your servers, with all of the code and videos and transcripts. You can get everything. If you want questions about OpenWhisk once you get started, there's a Slack channel and there's OpenWhisk. Oh yeah, cool. Or you can, if you want a more personal introduction, then you can find me on Twitter and you can find OpenWhisk as well. So thank you for listening, and I think we've got some time for questions. Otherwise, I'll be around at the end as well. Thank you. Burn your servers.
Hello, hello. Okay, you mentioned vendor locking, right? We can use OpenWhisk. I think it's great, and avoid vendor locking. So if I understood right, I can follow whatever are the setup instructions and put it to, let's say, EC2,
Yeah.
right?
Yeah.
Now, if I do that, I remove most of the benefits that you mentioned, right? Because I have a server to think about. I mean, so it's kind of, if I understand right, it's either we get serverless benefits with vendor locking, or we have almost no benefits and no vendor locking, right?
It's a good question. And yeah, I wouldn't run OpenWhisk myself, but you can. But remember, with serverless, right, what you're deploying is tiny functions with an interface. So if you look at all the big serverless providers, right, which are even the ones that are private, how do you migrate from one to the other? Well, you just have to change the interface a little bit. It's not a lot. You're not using a huge, complex set of vendor APIs to manage your application. It's generally, mostly your service is all code, and then there'll be a tiny interface that maps between your code and the platform. So if I wanted to take an OpenWhisk action and run it on Lambda, it's like a one-line change. They mostly operate in the same way, and they execute in the same semantics. So you're right that there's be some changes, but I think with serverless, it's much, much easier because you're not writing, you're not using a lot of custom vendor APIs. It's literally you just push the code with a tiny interface, and that interface is very similar across all the providers. And I think in future, we'll see standardization on the interface because all you're really telling it is, here's my entry point to my code.
So in that sense, it makes more sense to go directly for one vendor and then change later than, for example, use any of the...
and people, I mean, some people might like the open source one because if they just have their own infrastructure and they want to run it internally, or they can't put some of their data in the cloud. Another thing, the frameworks can help with that, because things like serverless framework can actually deploy to multi-vendors, and I think they can manage some of that for you automatically. But yeah, I think it's less of a challenge with serverless frameworks than, say, if you were going to go from App Engine to Heroku, it's completely different because they're a lot different APIs.
Hi. You said about service as a platform, and you were talking about lots of benefits.
Yeah.
But I was thinking about, we're going to change the code to be like a function, and then we're going to adapt it to run on the platform. But I'm thinking, are we creating a dependency to a platform? And if we want to change the platform somehow, should we have to rewrite everything, basically?
Yeah, that's a good question. And kind of similar to your question a little bit, that you're right that you need to implement the interface provided by the platform. But for all of the service providers, I mean, it's a tiny interface, right? So for OpenWhisk, you have to have a function with a specific name. With Lambda and with Azure functions in your JavaScript module, it's just whatever is returned from that kind of JavaScript file. So it's a very lightweight integration with the platform. It's not loads of configuration or loads of vendor APIs. So if I wanted to take an OpenWhisk action and run it on any other serverless platform, right, proprietary or not, I could do it in about 30 seconds, I think, because the interfaces are very similar between them. Because your services you deploy is mostly code, and it's just like a one line at the bottom to do that integration. So there is some integration with the platform, but it's much, much lighter weight than, if you had an app using Google App Engine and you wanted to move it to Cloud Foundry, although they're platform as a service offerings, they're so different that it's a huge amount of work to rewrite that. Whereas with serverless, I think one of the interesting things is, although you're using some proprietary cloud service, your integration is so light that it's not very hard to move off it.
So it's easy to move from Amazon Lambda to OpenWhisk, right?
It's super simple, yeah. It's like a one-line change, and I think we will see some standardization in the future. So eventually, in a year or two, all the vendors will support the same interface, so it won't matter anymore.
Okay, thank you.
That's it. All right. Thank you very much. I'll be around, for tonight, the next 2 days. If you want to come and talk about any of this kind of stuff, do. Or if you need some help afterwards, just ask me on Twitter, or go and find that repository, burn your servers, and be free of the tyranny of infrastructure forever. Thank you.